The topic that we are going to cover is homogeneity. Now, first of all, we need to define a homogeneous equation. A homogeneous equation, or sometimes expression, because it could be an inequality. So, homogeneous equation or expression. So, basically, an equation with same units for all the terms, an equation with same units for all the terms is called a homogeneous equation. So if all the terms in an equation have same units, then the equation is called homogeneous equation. For example, if we write an equation f plus ma is equal to work over distance. Now, interestingly, all these terms, F force, ma is also force, and work over distance is also force. So this equation is homogeneous. If we write base units for all the terms, here we will get kilogram meter second minus 2. For m it is kilogram. For a it is meter second minus 2. Here it would be kilogram meter square second minus 2 over meter. Now you see all the terms here have same base units. So an equation whose all the terms have same base units is called a homogeneous equation. So this is kilogram meter second minus 2. The second term also has units kilogram meter second minus 2. And on the right hand side, it is also kilogram meter second minus 2. So the equation was homogeneous. So it was a homogeneous equation. Another example could be example 2. Now, to check whether an equation is homogeneous or not, write base units of all the terms and see whether they are same or different. For example, you have an equation f into lambda plus force over density times area under root, and this is equal to energy over mass under root. Now the question is, check whether or not the given equation is homogeneous. Check whether the given equation is homogeneous or it's not. So this is a task basically. Writing units. First of all, what is base unit of f and lambda? Base unit of f is second inverse and base unit of lambda is distance, its wavelength. Its unit will be meter. Plus force will be in kilogram meter second minus 2 divided by density will be kilogram meter minus 3. Per meter cube is not a good idea. Writing it as meter power minus 3 is better because you should not write a fraction in fraction. So when you have fractions, avoid writing numerator and denominators with fractions. So it is meter square. Calculation becomes complicated. That is the problem. If you write a fraction in the numerator or a denominator, then fraction with fractions become difficult to solve. On the right hand side, we have unit of energy is kilogram meter square second minus 2 and unit of mass is kilogram and the under root of this. So basically it would become kilogram is cancelled out with kilogram is cancelled out with, now here it would be something different. So what you get is meter second minus 1 plus kilogram meter second minus 2 over kilogram meter minus 1 under root of this is equal to meter square second minus 2 and under root. Now on the left hand side, kilogram is cancelled out. It would be meter second minus 1 plus it would be meter power 1 plus 1 second power minus 2 under root and meter square second minus 2 under root. Now all the terms have same units. As you see, meter second minus 1 plus meter square second minus 2 under root meter square second minus 2 under root. So meter per second meter second. After doing under root, it will also become meter second minus 1. On the right hand side, it is already meter second minus 1. So it is homogeneous. Now one example which is not homogeneous. So another example is, for example, you have power over density into area cube root plus distance over time is equal to, so power over density into area whole power 1 by 3 distance over time is equal to force over radius का square into volume over density का square. So you have to check whether this equation is homogeneous or it's not. The first step would be substitute the units. What is unit of power? Unit of power is kilogram Now, if we substitute the units, unit of power is kilogram meter square second minus 3. Unit of density is kilogram meter minus 3. And unit of area is meter square. Plus distance is in meters, time is in seconds. Whole power 1 by 3 here. On the right hand side, force is kilogram meter second minus 2. Volume is meter cube. Radius is meter. Density is kilogram meter minus 3 but whole square. Now the first unit will become kilogram is cancelled with kilogram and it will become, it was kilogram meter power minus 3 meter square and power is kilogram meter square second minus 3. So it would become meter power 3. After simplifying this, for example, if we simplify this, after simplification it would become meter power 2 plus 3 minus 2 second power minus 3 whole power 1 by 3 plus meter per second is equal to, on the right hand side what you will get, kilogram is cancelled out with kilogram, kilogram is cancelled out with kilogram, and what you get is meter into meter cube into meter minus 2 into meter plus 6 second minus 2. So what you get is meter power 1 plus 3 minus 2 plus 6 second power minus 2. It is meter power 8 second power minus 2, and on the left hand side we have meter power 3 second power minus 3 whole power. So finally this would become meter cube second minus 3 whole power 1 by 3 then you have meter per second is equal to meter 8 so meter second minus 1 meter second minus 1, and the right hand side is meter 8 and second minus 2. So on the left hand side the two equations are same, but on the right hand side the equation is different. So meter second minus 1 plus meter second minus 1 so it is non-homogeneous. Since the base units are not equal, if sometimes the base units of the equation, if base units of all the terms are not equal, then the equation is non-homogeneous.